Hi, everybody. My name is Ryan Hamilton, and I am the product manager for all the elevation products at Maxar Technologies. Today's presentation is an overview of those elevation products, the use cases that many of our customers use those products for, and a bit of information about the technology that produces the different products. Over the last decade, we've made some huge strides in elevation products collected from satellite. And really, Maxar is the leader in this space. So before I get started, I want to just go through a quick presentation about who Maxar is.
At Maxar, we turn big ideas into successful missions. Missions that address change on Earth and power exploration into our solar system and beyond. As a partner to innovative businesses and more than 50 governments, we've been building advanced technology since humans first began exploring space, and since we first started looking at Earth from above. Maxar space infrastructure capabilities harness the promise of space for programs like in-space robotics to explore distant surfaces, power and propulsion systems that will push us farther into the galaxy, and communication satellites that provide connectivity across the globe. As a leader in Earth intelligence, Maxar offers situational awareness to protect national security and empower soldiers on the ground, satellite imagery products sourced from our industry-leading constellation, and location analytics that use machine learning and analyst expertise to monitor and detect change. From the images in the navigation app on your phone to the satellites that connects that phone to the internet, Maxar solutions connect Earth and space to make information accessible and insights actionable, all for a better world.
All right, so as you can see, Maxar is involved in a lot of different areas when it comes to space, but the area I want to focus on primarily for this presentation is our Earth observation capabilities and the Earth observation satellites that we own and operate that can collect all the imagery that we utilize for building of elevation models on a global scale. As you can see, our constellation currently has 5 Earth observation satellites in it, and the entirety of the constellation had 3 other birds that were collecting imagery for quite a while, but have since been retired. Adding to this constellation, early 2021 will be the new Legion satellites, and this is going to be a fleet of 6 new satellites that will increase our revisit to 15 times per day and triple our capacity of 30-centimeter imagery. So a huge amount of new imagery being added to the Maxar capacity as well as archive with this new Legion update. And this is all really important for the elevation products that we're producing and our ability to produce these elevation products globally. So when we talk about elevation and Maxar, it's really important to point out that we're utilizing photogrammetry, multi-view, and partner processing to build a very comprehensive suite of elevation products, really the industry-leading suite of elevation products for global elevation. I want to jump into a little bit of the details of these different technologies that are mentioned here, starting with the stereo collection methodology that you see on the left. Now, traditional stereo is a technology that's been around for a few decades, and Maxar produced one of the leading stereo collecting satellites with the WorldView 1 platform. This satellite was actually tasked by NGA in its development to be a stereo collection satellite. And with stereo collection, what happens is as the satellite's approaching a target, it will capture an image, it will pass over that target and look back and collect a secondary image of the exact same area. Those 2 images from different viewpoints allow for a phenomenon called parallax. And when you utilize parallax, you're able to extract a 3D surface from those 2 different viewpoints of the same area. Now, The big advantage with stereo is that it's on demand. So if temporal currency is really important to someone, this is the best technology out there because we can task the satellite to collect an area as of that day, if that's what the customer needs. And that model will then have a validated timestamp of when that collection happened, the date and the time. The disadvantage with stereo is that because you're only taking 2 images, you can end up with occlusion if you have steep terrain or if you've got multiple buildings, urban corridors, things like that, where by only having 2 viewpoints, you may not see into all the deep areas of occlusion. This can cause problems with the accuracy and the fidelity of the 3D model. Another issue with stereo photogrammetry is that you do have to have ground control points to get the higher accuracies on the 3D models. So a secondary technology has been developed, and this is something that really has only started being utilized in the last 5 years or so. And this technology is called multi-view photogrammetry. And with Maxar, we're able to leverage our full image archive over all the areas of the Earth in order to take multiple images in an image stack and do what's called semi-global matching or pixel matching on each of those images. So you still get the parallax effect by utilizing multiple images from multiple viewpoints. But instead of just using 2 images, what you're doing is using a stack of maybe 10 or 20 images with different look angles of the same area. So that problem that you had with stereo where there was occlusion, things might be blocked because of the view angles, is now almost completely alleviated because of the multiple view angles that you're getting with multi-view. The other big advantage is that because you're combining multiple images together in a single location on a precise pixel by pixel basis, you're able to model out a lot of the pointing errors that you see in the satellite as far as accuracy. So no longer do you need ground control points to get an accurate position for your 3D model. Because you're utilizing all these images and sort of doing an average of the error on all the images, everything that comes out of our multi-view process has a CE and an LE90 of less than 3 meters. So a spherical error, an SE90 of 3 meters for those elevation models. The other benefit of utilizing multi-view is that the imagery comes from the archive. So instead of having to wait for tasking, where it may be over cloudy conditions and it may take some time to actually get a stereo collect, we can go into the archive, pull that imagery instantly, and utilize it to build these high resolution, very detailed 3D models. That's another big advantage is because you're using so many images, you can actually leverage the full native resolution of those images into the resolution of your 3D model. So since we utilize 30 and 50 centimeter imagery in our 3D model production, we can produce 50 centimeter elevation models for anywhere on Earth utilizing this multi-view technology. The final technology I want to talk about is speculative global off-the-shelf data. So instead of doing tasking on demand with stereo, this global build is a speculative collect utilizing a different sensor than one of the Maxar sensors. The speculative build of a product called AW3D Standard was actually done by the Japanese space agency JAXA using their ALOS satellite and their PRISM sensor. They collected over 3 million tri-stereo pairs over the globe and built a very high resolution global elevation model that for customers who are interested in quick delivery times, medium resolution elevation, and lower price points for large regions, this type of product is critical to our elevation suite. So I want to dive into the basic groupings of the elevation products that we offer that are based loosely on those technologies I just explained. So the first one is Advanced Elevation Series, AES. This is where we leverage our stereo tasking capabilities to produce 3D models on demand for customers that really have need for temporal currency when they're talking about their elevation models. What does the terrain look like today? I need to have a model that shows me that. Therefore, I need to have tasking, and AES is the product that will build that 3D model for me. Vricon technology is the wide area, very rapid, high resolution 3D multi-view that we talked about. This is the ability to leverage the archive, scale very rapid production of large areas at high resolution and high accuracy. And then the third product is the AW3D product line that's offered by our partner NTT Data. So as I mentioned before, NTT does own the AW3D standard global DEM that Maxar is a reseller of. This product is the highest resolution global DEM available at 5 meters and 2.5 meters, and is offered both as a surface model, DSM, and a bare earth DTM. But NTT also produces these high resolution multi-view DEMs, like the Vricon technology, utilizing the technology of the multi-view semi-global matching, pixel-to-pixel matching, as I mentioned, and the Maxar image archive to build DSMs, DTMs at high resolution, as well as 3D models. So I'll dive into each one of these product groups with a little more detail in the following slides, starting with the AES product. As we mentioned, AES is stereo, right? Stereo has been used by Maxar customers and partners for decades to produce their own elevation models. For example, the University of Minnesota produced the Arctic DEM utilizing Maxar satellite imagery. Photosat's another partner of ours that does some amazing work with our stereo imagery in mining locations where they're able to produce very high resolution LiDAR-like elevation models that have 15-centimeter accuracy utilizing stereo imagery. So quite impressive for companies that are looking to get LiDAR-like quality out of stereo tasking without having to hire a LiDAR company to go fly it. So the advantage with stereo is this idea that you can get a picture of what the Earth looks like today. But the advantage of AES is not only do you get that tasking capability as part of your product, but Maxar does the production for you. So you don't have to do any in-house production to get your elevation model. And that's really, when it comes to the AES product, you know, if you are interested in building your own 3D models, of course you can always order stereo from Maxar. But if you would rather have that work put to us and have us take care of it, we're happy to do that, and that's why we provide the AES product line. So just some in-depth on what's offered within the AES product line. Really the variation between the product tiers here is the resolution. So we offer highest resolution at 2 meters, and then a 4 meter and an 8 meter. We also offer vertical accuracies of 2 meter, 4 meter, and 8 meter. So for the 2 meter and 4 meter accuracies, it does require the ground control points that I mentioned earlier in order for you to get those stereo models in the proper location on the map. For the 8 meter, because of the tolerance on that vertical error of 8 meters, we don't have to have ground control points for that product. If you look at the images on the bottom, you can really see the difference that resolution makes when talking about elevation models. The 2 meter on the left, it's pretty clear to see those edges of the buildings, the road edges, and so forth. But as you move more to the right with the 4 meter and the 8 meter, it becomes more of a surface model that looks to be maybe melted ice cream or an overlaying sheet. You still get a sense that there's buildings there, but you don't see the definition of it. So of course there's price differentiation with the different resolutions, but as far as build scale with the AES product, we can build up to 10,000 square kilometers for an AOI, and it's pretty scalable. The long pole in the tent for the AES product is the tasking component. If it's an area that's going to have clouds or persistent snow, it may take longer to get those collections to build this model, but once we have the imagery, the production is relatively quick. As far as the use cases for AES, because of that temporal component of having up-to-date information, it's really vital in the resource extraction exploration field. When we talk about exploration, what we're talking about is the identification of geological features that may be indications of subsurface reservoirs of either hydrocarbons or other resources that geologists may be interested in the lithology of the subsurface. So identifying where there's faults, ridges, depressions, domes, all those type of things that you can see within the elevation model can indicate where maybe seismic surveys need to happen, or potential lithology studies. As far as resource extraction, this is where the AES product really shines because of its temporal currency. If a mine operator is interested in measuring tailing piles over a month-long period, we can task at the beginning of the month, we can task at the end of the month, we can use those two elevation models to do a difference comparison and figure out what the change in those tailing piles have been. It's also vital for looking at progression in mine development, as well as maybe slope analysis to make sure that slopes are stable. All use cases that we've sold multiple AES products for. So the second grouping of the elevation product is the Vricon product. And as I mentioned before, Vricon relies on multi-view photogrammetry to produce their elevation models. And this is a cutting edge technology that Vricon is really the industry leader in being able to perform these algorithms at a massive scale. Not only that, because Vricon relies on multiple images over an AOI to build an image stack, Maxar is really the only one that can contribute the image depth needed to produce these types of products. So it's a very unique offering, and it's really kind of an exciting product. I want to talk more about it here. I think many of you might have heard that just recently Maxar and Vricon became one company. So this is very exciting for us. It's been a process that's been in the works for quite some time. Vricon was actually formed as a JV between Saab and Digital Globe at the time, back in 2015. And the reason that this partnership made such great sense was that Saab, the defense company, brought the technology of multi-view photogrammetry to the table, while Maxar, or Digital Globe at the time, brought the dense image archive into the equation. So if you think of it as a car and then Maxar bringing the fuel to fuel that car, it was really a relationship that made a lot of sense. And as I mentioned before, this is a unique partnership that no one else in the industry can really mimic except for these two parties. So how does it work? Well, I got into a little bit of the technology, but let me do a deeper dive. On step one on the left, what you see there is 8 years of image collection over the city of San Francisco. The green sort of rays at the bottom are actually the view angles of all those different collects from 2012 to 2020 over the San Francisco area, and the different look angles that were used. So all those images are then put into step two, which is the automatic processing. And this is a key piece to Vricon's scalability and their mass production capability, is that everything is automated within this production line. So the imagery is selected for having certain criteria as far as look angles to provide that parallax to do the 3D, as well as cloud cover, temporal components, and even leaf on, leaf off conditions and things are considered when that image selection is happening. The algorithm then does the semi-global matching to match each image pixel from each image to the other one. So when we talk about stereo, really when you're trying to match two images, you might use 5 correlation points, which are recognizable features in the image, to try and tie those two images together or correlate them. With the semi-global matching technology, you're now doing that on a pixel by pixel basis. But not just for 2 images, it may be 20 images. So instead of 5 correlation points, you suddenly have 500 billion correlation points. It's a heavily graphically intense process that uses a huge amount of compute, but the output is what you see in step 3, a true textured 3D surface model. So when I say true textured, what that actually means is that we've built the 3D surface model and we haven't just overlaid an image onto the side of it. The algorithm actually picks the best pixel for each location of that surface model, extracts that pixel, and then places it into its proper location. So you end up with a synthetic image of the AOI that's been developed over, say, 20 images. And this is really interesting in that you get this very nice global consistency for these textures. You sort of are able to filter out a lot of the shadows and the harshness that you might have in an individual optical image and build sort of this simulated texture that is a true pixel texture. So we're looking at smokestacks here in image number 3, but for instance, if it was buildings, the location of each window on the side of that building would be with its proper X, Y, and Z location within a 3-meter spherical error. So quite impressive when you compare it to the old sort of image overlay technologies to build photorealism. This is actual photorealism in 3D that the Vricon process is doing. As we move to step 4, that 3D surface model can then be processed into multiple derivative products. So on the top left, we've got a digital surface model. Underneath that, we have a point cloud. Underneath that, we have vector features. Up at the right, we have the true ortho product, which is a nadir view of that simulated image, so looking perfectly straight down on it. We have the 3D features now getting a true surface texture, and then 3D features in a nadir view. These are all products that can be derived from that core product. And the beautiful thing about everything being derived from one single product, the way that Vricon does it, is that there's perfect co-registration of all these different products. So as a customer, if you're interested in, say, land use land cover along with 3D vectors, let's say, the land use land cover and the 3D vectors will perfectly align. If you want the true ortho and a DSM, if you overlay that DSM or the true ortho on top of the DSM, you'll have perfect alignment. So I just want to take a little bit of time to dive into the full product line. On the left, of course, is their flagship product, the True Texture 3D surface model. This is a raster surface that it does not have individual vector features in it, but it has photorealism to it, where each location, even on the sides of buildings, has an accuracy specification of under 3 meters. The DSM and DTM that's derived from that is also that same accuracy specification of an SE90 3 meters. There's a 5-meter resampled product, which is a lower resolution, lower cost DSM and DTM that we can offer. There's also a point cloud. So instead of offering as a GeoTIFF, we can offer as a .las and utilize the RGB values that were contained in the image pixels to attribute each of those LAS files. I mentioned the True Ortho product. This is the nadir view straight down with no occlusion that is used from the optimal pixel selection in the algorithm. Another interesting thing about this True Ortho product, for instance, if you wanted to see road paint on streets in a city, because it's choosing just the proper road pixels, you won't have any cars on the street in that image of the city. So pretty amazing how it's able to build these simulated images. And then that nadir view is really key if you're trying to do any sort of feature extraction like building footprints or anything like that. You've got not only the 3-meter accuracy of the positional accuracy of that image, but you've got that top-down view. So even if you're just digitizing what you see as the rooftops, it's actually going to align perfectly with the base. And like I said, all the Vricon products are co-registered. So Vricon offers those 3D vectors. You wouldn't even need to do the 2D extraction if you want to just buy the 3D vector product directly from the Vricon technology that you see on the right. That one is specific to the telecom industry, where it's elevation, terrain, plus 3D models of buildings, bridges, and vegetation, as well as clutter classification or land use land cover as a bundle. But any of those products are also available separately. So I want to talk a little bit about the true surface texture versus the 3D features, because though they look somewhat similar, there's a big differentiation. The 3D surface True Texture photorealistic surface model is great for simulation applications, planning applications, any sort of mission rehearsal, things like that, where you need to get a view of what the world looks like from maybe a bird's eye. But when it comes to actual AI, machine learning, computer vision, things like that, where it's more important that those features all be identified and maybe attributed with certain attributes or changed and replaced with different features. That type of work really requires these 3D feature maps. And as I mentioned before, this co-registration of the 3D features with the other vector or Vricon products is a key piece of what really differentiates them and enables not only the scalability of products around the globe to be built with co-registration, but any sort of updates that happen, that those products are going to match up to the previous data as it was built before. So again, just emphasizing on this co-registration piece, here's the 3D surface, and here is the feature vector model. If we talk about, use case applications of terrain and the 3D features and the 3D surface model, here's a use case that I think is kind of interesting in putting them all together. We've got a island area here that is subject to storm surge and flooding due to storm surge. And if you see, as I click on it, we can see what the impact of a storm surge would be to this area. And you can see how, some buildings are just on the edge of the inundation. Some are actually in it, yet they may actually still be on dry land around them, but there's water all around them. Now, the interesting thing is you change this to a vector feature map is each one of these buildings now can be attributed with an address and with an owner and with an insurance company and insurance coverage information, all that type of information that can help in planning to understand for a future emergency, do we have the proper preparation? Is the insurance company prepared? Is the reinsurer prepared? That type of information is not only visually in here, but we can utilize a feature map to extract it as a database. So the last grouping I want to talk about of our product suite are the NTT AW3D products. I mentioned before that the AW3D standard product that you see on the left on this table is our global mid-resolution, low-cost offering for the market. As I pointed out before, for a lot of customers, this is really a key piece in being able to say, we need elevation for the whole country or the whole continent because we're doing X, Y, and Z as far as planning, but we don't have the budget to either task it with AES or to utilize the Vricon technology to build these super high resolution models. We just need a sense of what the terrain looks like and maybe what the vegetation and buildings look like in that area. And this product can be delivered relatively quickly because it is a pseudo off-the-shelf product, meaning that it's been collected, it's been processed. It just needs to go through the final steps of editing before it can be delivered. The second product that we see from NTT in the AW3D line is AW3D Enhanced. Now, this is utilizing the same technology that Vricon utilizes as multi-view technology, but is much more focused on project-specific work. So smaller areas, not as scalable, and more suited to use case type work, like you see on the next column, the 3D building models, which are used for telco planning and city planning, as well as a full telecom bundle used for that RF propagation planning. If we talk about the AW3D standard product, it's had multiple uses around the globe because it is globally available, from mapping to geologic studies to wind power, disaster prevention, and environmental. And it is global, but it does have some voids. So these black areas in this map show where there has been clouds or persistent snow during the collection of the AW3D product. Those areas are infilled with SRTM data that's been resampled to the 5 meter or 2.5 meter. So it is a void-free product, but there are some areas that have SRTM data in them. If we look at a comparison between the SRTM, however, and the 5 meter AW3D standard on the top right, you can see the level of detail on that AW3D standard product. It's quite a lot more detail than you would get from just a standard SRTM product. And then if we compare the 5 meter to the new 2.5 meter that's now available globally, you can see that as you go from the left column, which is the 5 meter, to the right column, which is the 2.5, the buildings show up with much more clarity. So there's just more detail in this 2.5 meter. And it's also done as a 32-bit float. So if you see the red line on the profile on the bottom right that was taken up that highway, the dotted blue line underneath it is an actual LiDAR profile. And then the green and the yellow stepping lines are the old 16-bit integer 5-meter process. So by using 32-bit, you get a much smoother transition between elevations, and it mimics that LiDAR much more closely. And again, this is available globally. As far as the enhanced products go, AW3D, enhanced telecom, these are products that have been in the market for a while. NTT has been a trusted partner of Maxar's for quite some time. And within Japan, NTT has been the leading telecom geodata provider for over a decade now. They build models that are very specific to the needs of the RF engineers and are more of what we would call a traditional telecom model, where the ones that Vricon produces are much more scalable and built at a lower price point using automation, though not as crisp and clean and meeting the expectations of the RF engineers as the NTT product. We find that the scalability as 5G starts to roll out is becoming a real crucial component of these telecom rollouts. So just talking a little bit about the components of a telecom geodata set over a sample area in Toronto. You can see that the first piece is the terrain data, the DTM, the bare earth. The next would be the digital height model. So within the higher skyrise or skyscraper section of Toronto, you can see that there are rooftops that are the lighter colors. Those are the taller buildings. We also do feature classification, so identifying what in the DHM is a building, what's a tree, and what's a road, what's a water body. All those features are identified. And then utilizing those identifications, we derive the footprints, which are multi-tier footprints. So think of it as a wedding cake, as there's different tiers in the building, all those different pieces are going to be collected, and then they'll be attributed with the DHM, which will give you that 3D model we saw as the telecom providers use to plan out their networks. So that basically covers the three groups of elevation products at Maxar. But there's another elevation product that isn't a ground-based elevation product. This is actually a seafloor elevation product called satellite-derived bathymetry. And this is produced by our partner T-Carta. They're utilizing our nearshore collections to build 3D models of the seafloor in depths as deep as 30 meters, where there's the proper water clarity in order for the satellite to be able to see the seafloor bottom. And what they're actually using instead of stereo or any of the photogrammetric means is a signal strength algorithm to understand how much water that signal has penetrated through in order to derive a depth. And these bathymetric models are available in 2 meter and 10 meter. And they're also able to do seafloor classification, so identifying where there's sand, coral, reef, these type of things. So any sort of bathymetric product, we also have an elevation component that can cover those. It's interesting to point out that this product, as well as the AW3D product and the AES product that I mentioned, are all available on the NMSO schedule. So if you have any questions regarding any of these products or any opportunities that you might think these products might fit into, please feel free to contact myself, Ryan Hamilton, or John Roos, the sales director for Canada, and we'd be happy to discuss further any future opportunities that you see.
Welcome back, everybody. Thank you to the Maxar team for putting that excellent presentation together. Ryan, can you hear me?
I sure can.
Hi, Ryan.
Hey.
Thanks for that. So yeah, we've got some great Q&A, but before we pitch into that, I just want to always thank the Maxar team again for being our gold sponsor for this year. Okay, let's jump into the first question from the attendees. For, I think it's Vricon 3D products, how can I browse data availability for AOIs? Can we target a AOI for a particular date range? For example, what if I wanted to look at terrain data before a landscape occurred?
Yeah, absolutely. So that's a great two-part question. On the first part, we do have what is called the construct of where Vricon data has already been built out. Unfortunately, that construct, due to security reasons, is a proprietary data set that we can't share directly with customers or partners, but we can run a feasibility very quickly if there's an AOI of interest to see if that's already off-the-shelf data or it would require a new build. As I mentioned though, with the Vricon process being so scalable, so automated that even if it is new build, it's a very quick turnaround for those AOIs. On the second part of that question, this is the beauty of multi-view photogrammetry, this ability to mine the archive, right? So just as the participant that asked the question stated, if I want to build a terrain model with a certain date, I can go into that archive and say, hey, we know a landslide happened in 2018. I want to build a DEM pre-2018, so I'm going to utilize all the imagery from the archive of pre-2018, build a multi-view 50 centimeter DEM, and then I want to build a post-2018 DEM of that same area. And then you can run a differentiation between the two. As I mentioned before though, they are a blend of temporal pieces. So after the landslide happened in 2018, if say engineering crews went out there and started shoring up all the debris and cleaning it up, we'll have imagery when it was fresh, we'll have imagery a week after cleanup started, and maybe 3 weeks after. They all get blended together in a multi-view. So in some instances, I like to refer customers to a blend of a Vricon product for pre-disaster to build that DEM, see what it looked like, and then post-disaster, put in that temporal currency AES product, the advanced elevation stereo with the stereo tasking.
Great, thank you for that. Next question. Do you have a global coverage and catalog of the Vricon 3D product? Can you request these Vricon products on a regional or country basis?
Yeah, so that tags a little bit of the first part of question one. Like I mentioned, the construct is proprietary. At this time, we just can't share the locations of all the built out models. And definitely, if there's a request for a whole country, we can check the feasibility, see if that country's off the shelf already and available for immediate delivery, or if it needs to be built. But it's one of those things where talk to your Maxar sales representative, we can get that feasibility run.
Cool, thanks. Next question. Can satellite-derived bathymetry products be used for rivers and lakes, or are they more useful for deeper water bodies?
Yeah, the turbidity of the water is a key component. So when we talk about larger lakes, like for instance, the Great Lakes, there are definitely areas within the Great Lakes that we can do satellite-derived bathymetry. If we're talking more like bass fishing lakes or something that have more of a muddy consistency to them, we're not going to be able to get the penetration to be able to do the measurements. So it really depends on where those lakes are. As far as rivers, we haven't, as far as I know, seen much success on rivers. It would have to be a very clear and slow moving water body in order for it to work.
Okay, great. Next question from Marco. It's great. You showed worldwide or near worldwide availability of Hire's elevation products. What is the age and resolution of the source data, and how do you plan to update where needed?
Yeah, so the update process, with the global DEM that we have, which I mentioned as AW3D standard, this is the one from NTT data that comes in the 5 meter and the 2.5 meter resolution. That was collected between 2009 and 2011. So it is the ALOS sensor with the prism instrument on it is no longer collecting data. So that is sort of a time-stamped global elevation data set. As far as updates for it, we do utilize the AW3D enhanced process where we'll utilize Maxar satellite imagery to update areas at a 2.5 meter or 5 meter and fill in that if required. We also do that for some of the void work that you saw there. As far as the Vricon products go, there is the ability to ask for a refresh if it's already off-the-shelf data that we have available, but the customer needs more recent imagery added. We can do a refresh of that build area, but primarily right now, Vricon's goal is to build out the entire surface of the Earth as 3D and then start on the refresh post build out. So right now it's based on the customer asking for an update. There is no set schedule on the refresh for the Vricon product.
Great. Next question. In case any of these data is needed as a base product for a specific final product, do you have other sales plans in terms of packages, agreements, projects, and whatsoever?
Yeah, I'm assuming this would be sort of like a bundled offering where we would have an elevation data set along with maybe a secure watch subscription or some sort of bundle like that. And that's the beauty of Maxar sort of having all these pieces of geodata and remote sensing data, is that we can definitely offer sort of bundled products depending on the customer needs. So if there is an elevation and imagery and maybe information layer kind of request, it's something that, meeting with the customer, figuring out what those requirements are and bundling something together that makes sense from an economic perspective is what we try and do.
Great, thanks. There's a question here from Sebastian asking about geological data. So he says, what about geological data? How can underground layers be captured? You short mentioned geology.
Yeah, so really what it is not so much subsurface identification, but identifying surface features like fault lines and ridges and things like that to assume what that subterranean lithology might look like. So if you've got, some sort of fissure that's on the surface that you can see, maybe that's a fault line underneath. So I know with the lithology, I am not a geologist. Unfortunately, I don't have a background in that area. But when we have been working with oil and gas companies, they have done evaluations of the surface lithology to then plan out their seismic surveys, understanding where there might be oil reserves based on some of those surface features they've identified.
Great, thank you very much. We've got another question. Thank you for the presentation. I'm wondering, what technology do you adopt to store, manage the image data with huge volume? Is a data cube or other similar technology in consideration to manage and integrate image data or facilitate the analysis process?
Yeah, so we do have, we're at 120 petabytes of image data with Maxar, and we work very close with Amazon and the AWS services to put all that imagery into the cloud. We actually, at our office, were the first ones with the snowmobiles, the large semi trucks that transferred all that imagery into servers on those trucks and then put it into the AWS cloud environment. So our reliance on the cloud, because of this mass amount of data and the scalabilities we need, is a huge component of what we're doing. I have not heard anything regarding data cubes and the storage component, but this is something, if you want more information on it, I can reach out to some people within the company and see if I can get some info.
Great, thanks for that. We've got another question here from Michael Matthews. For bridge and dam monitoring, what kind of spatial accuracies can be achieved? Is it cost effective compared to traditional terrestrial techniques?
Yeah, so if you are looking to measure sag within a bridge and sag differentiations, you're probably not going to pick up that type of detail from the 50 centimeter multi-view photogrammetry. We rely on the algorithms to actually get us the clean edges. We will do the vectorization of features. So think of that as like a pseudo break line. So when we talk about DAM accuracies, we aren't doing traditional break line work with the Vricon product where we build a stereo pair and then a technician is viewing in stereo that edge of the DAM and putting a break line there. We can do that kind of work with the AES products, but with the Vricon products, it's more a reliance on the algorithms to find that edge based off the multi-view photogrammetry and then to create a vector identification of that edge based off those same algorithms. So a bit different than traditional break line work. And like I said, any sort of sag measurement on power lines, bridges, or if you're trying to understand, you know, as far as like depressions of ground, surface ground due to fracking, either, you know, injection of the fluids or removal of the resources and seeing what those ground deformations look like. That's more of a SAR process to measure those, you know, sub-millimeter measurements, millimeter measurements.
Okay, great. Well, that brings us to the end of this session with Maxar's elevation products. Really interesting stuff, obviously very important. In the chat window, we've got some email contacts for Maxar. I want to thank Ryan and Rachel on the Maxar team for helping, and of course, John Roos and the rest of the team for putting this together. Thank you for being our gold sponsors.
Great. Thanks for everyone's time today.
Thank you all. Everybody, we're all moving over to another room for the diversity leadership panel. So I hope that you will all log out of this room. We're going to be closing it. Go back to the GeoIgnite schedule and have a look. It's a geospatial diversity leadership panel that we started last year that was very interesting and exciting. And I'm going to be joining everybody over there as well. All right. Thanks, everybody. See you soon.